Welcome back. In this video, we are going to solve problem 10-88 that is taken from chapter number 10, Strain Transformation, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. And the topic that we are covering is theories of failure. So statement is if a solid shaft have diameter d is subjected to torque T and moment M, show that by maximum normal stress theory and the maximum allowable principal stress is this one. So you can see this is the shaft that is subjected to two equal and opposite torque clear that is producing twisting effect, and there is a moment that is acting in the same plane but opposite to each other produce bending effect. So you have to determine that maximum allowable principal stress is this one using maximum normal stress theory. So let's start with the solution. Okay, so the first step is that you can see that due to movement we will have bending stress, and this bending stress I will write it over here. We will have bending stress, and this bending stress is equal to m into c divided by I, where m is the moment, c is the radius, and I is the second moment of inertia. And due to torque we will have shear stress, and that this shear stress is equal to T into C divided by J, where T is torque, C is the radius of this shaft, and J is the polar moment of inertia. So first we will find this C. So C is radius, as we have been given diameter, so radius is equal to D divided by 2. And the second moment of inertia for circular shaft is equal to pi by 64 d power 4, and J polar moment of inertia is pi by 32 d power 4. So you have all these values, so just plug it. This will be sigma x and this will be tau of xy, because this is our x-axis, this is our y-axis, and this is our z-axis. So moment about z-axis will produce normal stress in x direction. So sigma x is equal to moment d is c is equal to d divided by 2, and I is pi by 64 d power 4. So this 2 will cut with this, so it will be 32, and we will left with 32 m over pi d cube. So I will write sigma x will be equal to 32 m over pi d cube. This is the value of bending stress. The stress is generated due to bending moment. Now we have shear stress tau of xy, and that is equal to T. C is d divided by 2, and J is pi by 32 d power 4. So from here you will get tau of xy will be equal to 16t over pi d cube, because this 2 will cut with this, so it will be 16, and 1d is cut with this, so we will have here cube. Okay, this is shear stress. Now you can see we have state of stress in which sigma x is 32 m over pi d cube. You do not have sigma y, which is equal to 0, and shear stress tau of xy is 16t over pi d cube. Now according to maximum normal stress theory, which is also known as von Mises criteria, so we have to find sigma 1 and sigma 2, which are the principal stresses. So let's move and find sigma 1 and 2. So we know that sigma 1 comma 2 is equal to sigma x plus sigma y divided by 2 plus minus under the root sigma x minus sigma y divided by 2 whole square plus tau of xy whole square. And from here you have to put the value. Sigma x is 32m by pi d cube plus 0 divided by 2 plus minus under the root 32m over pi d cube minus 0 divided by 2 whole square plus tau of xy is 16t over pi d cube whole square. Okay, so what we will get is sigma 1 comma 2 is this will cut with this, so it will be 16. So I will get 16m over pi d cube plus minus the same here we will have 16m over pi d cube whole square plus 16t over pi d cube whole square, and that will be equal to 16m over pi d cube plus minus under the root. Now you can see 16 over pi d cube whole square is also available in this term as well as in this term, so we will take them common. So it will be 16 over pi d cube whole square, and we will left with m square plus t square, and your sigma 1 comma 2 will be equal to 16m over pi d cube plus minus this term will come outside the square root, so we will have 16 over pi d cube, and in square root we will have m square plus t square. Now you have two stresses, principal stresses. One is sigma 1, which will be equal to 16m over pi d cube plus 16 over pi d cube into m square plus t square, and another one is sigma 2, which is 16m over pi d cube minus 16 over pi d cube into m square plus t square. And you can see that from sigma 1 and sigma 2 we can see that sigma 1 is greater than sigma 2. It means that your allowable stress, principal stress is our maximum principal stress is sigma 1, which is equal to 16m over pi d cube plus 16 over pi d cube into m square plus t square. Okay, now what if you can see in both these terms we have 16 over pi d cube is common, so if I take 16 over pi d cube as common, so here we will have m plus this m square plus t square under the root. So final allowable principal stress is equal to 16 over pi d cube into m plus m square plus t square under the root, which is the answer. And you can see, you can compare it with this above equation. Both have the same. So this was all about this problem 10-88. I hope you have enjoyed this video, and with this you have also learned this problem. If you have any question, you can ask me in comment section. Thank you for watching.